Hey ng-conf, Okrushko here, and I'm super excited today to present you ngRx ComponentStore, the latest addition to the ngRx family of state management libraries. So my topic today would be filling the gap in state with the ngRx ComponentStore. We'll take a look at what problems we're trying to solve with the ComponentStore, what's the service with the behavior subject, and where it has its own disadvantages. And also we'll try to look at some of the use cases for the ComponentStore. Before I continue, let me introduce myself. So I'm Okrushko. I'm currently a software engineer at Firebase at Google. I'm part of the ngRx core team. I do also organize Angular Toronto. So if you have an exciting topic, please reach out to me. And I'm part of the fantastic group of people at indepth.dev. So one of the greatest minds of all time, Albert Einstein, said this once: synchronizing state within the application and the backends is one of the most complex tasks that developers have to solve. Well, actually, he was with us just before the internet was created, so he probably didn't see this problem. However, I'm sure if he was with us today, he'll definitely say that. So, what is the problem we're trying to solve? What is the synchronization state, and why is it such a hard problem? Let's start with the simple example. We have a page of the store, for example, and this one shows you the list of the products that we have in the cart. So this is like a cart page. And we have also the cart icon component that also needs to show how many items do we have in the cart. For example, in this case, 4 items. So let's take a look at this example, and let's take a look at this component. So this component needs the cart items count, and it should be a simple number. How can we provide that data for this component? Well, there's multiple ways. One of them could be through the input, but then we'll still also need to have a container component above it that talks to the services and basically pushes the data into this component. Great, that's one of the examples. The other example, we can just go straight directly to the service and ask what cart products do we have, and then we'll use some map operator and have some function that would transform the items of the cart that we have to a single number, right? That the one that would be displayed by this component. So we can inject the service and get the cart products and get our number out of it. Great. And let's see how this service would look like. So here, this get cart product would basically be a thin wrapper around the HTTP client, which will do the API call and give us the observable of those cart items, which will be later reduced to a single number. Great, that kind of works, right? But let's take a look at the structure of this page a little bit closer. So we have this cart icon, right, component, which is part of the header, and that header is there, okay? So then we have a bunch of products that also need this information, by the way. So we have multiple cart products components, which basically they live in the cart page. So this is our structure, which in itself lives in the in the router outlet, and in the end, all of it lives in the app. So this is basically how our components are nested. Let's break it apart and take a look at it as the component tree. Okay, so this is what we have. So how can we provide this data, the cart icons data, to the cart icon, to this, and also to the cart page, which also is interested in this cart items? Well, one of the ways we can do it is basically provide the data to the app somewhere, and then that would be passed down through the inputs to our components that actually need that data. But you can see that approach doesn't really work, and it's really not the best approach, because now your header is just passing this data, no use of it. It's like called property drilling. So we definitely don't want to do that. So what can we do instead? Well, we can basically provide that data, inject into both those components, and provide that data, the cart item data that it needs. But at the same time, if they'll be both of them will be using the get cart product method, which is stateless at that point, they'll each request this data multiple times, but use it only once, right? So we don't want to have those extra requests. So how can we do this? Well, one of the ways we can do it is instead of exposing this getCartProducts method directly to the components, we can call it within the cart service and basically share replay. That means that the result of it would be shared amongst all of the components that need that data. And we'll expose some property called cart items $, which would be a reactive observable property providing that data. And then in our component, instead of calling it directly, right, instead of calling the getCartProducts, we can just remove that and instead use that reactive property. Great, so we have that solution. However, that means that the data we get once this cart product details, and that's it, right? So that data becomes stale. This data, in fact, could be changed in multiple ways within our application. For example, we can remove items from the cart, we can purchase it, we can remove everything, or we can even add new items to this to the cart. So our cart items data is not static, it's dynamic, it's changing, and there's multiple ways we can change it throughout the application. So how can we approach that? Well, we need to rethink how we expose this cart items observable property. Instead, what we can do is service with the behavior subject approach. So that means that our cart service is a stateful service that has the subject in it, and then it's exposed as an observable through the cart items, just like we had before. Now, every time we call, we need to add the product, for example, we can call the method, but however, we change this method. They no longer return observables for us. They'll return void, so they don't return anything. But inside, they do the call and they subscribe to that network request. And then the result of that array, the newly added array, they'll just push it to the subject inside. So this is known as the service with the behavior subject approach. It works really well because now our component still doesn't care what's changing the data, who's adding products, who's removing products. All it needs to know that this cart items is changing over time, it's observable, and that observable is reduced to a count and basically displayed in our cart icon like this. However, one thing we need to do now as well is we need to let the service know that we're interested in this information. So getCartProducts, we have to call it. It also returns void, but it no longer returns us observable back, right? It basically triggers something inside, so we can use it as an event to do something. All right, so this is a great approach and it works well for a lot of situations. However, there is a slight problem with this, and this is why ComponentStore solves the problem well. For example, the user really wants to add many products to the cart, and it clicks user click many times this add. So we have the first click that goes in, right, and then user clicks it again would trigger the next one. So we have a second add to cart click. However, in the network request, it could happen that the second request arrives before the first one, the result of it. This is what we call race conditions. And right now, with our service that's structured right now, there's no way we can handle any of those because every time we click add, it triggers a new request. So this is where effects really shine because they can allow us to control the race conditions. Be it in the global NgRx store or in the component store, we have effects to handle things like that specifically. All right, so the race conditions is what the effects are for, and this is what we'll be using in our component store. Let's take a look at how our component store is constructed. Let's take a look at its APIs. So this is a component store, and it's a completely standalone library that has nothing to do with the global NgRx store. It's basically one file with 300 lines of code and maybe less soon, and it has a few operators. So it exposes us a few APIs. For example, it should read, write, and handle side effects, just like any state management library. So for read we have select, for write we have an updater, and for the side effect we have an effect method. Let's take a look at them closer. So instead of our cart service, we will create a cart store, which would be responsible for this state of the cart items. The first thing we'll do, we'll declare an interface that will be saying that which state it holds. For example, in this case, it's cart items, it will hold that state. Then we'll extend the component store and we'll pass this interface as a generic into the component store. So now we are tying this cart store with the component store. Then we'll inject any dependencies that it has. For example, in this case, it'll inject the cart service. However, the cart service, we're reverting back to fully stateless, meaning it doesn't have any behavior subject in it, and every call to add a product or get the products would actually do the API call and return us observable back. So we're basically returning that back. Okay. Then we need to initialize the state. The cart items, empty array is how we would initialize this one. So how would we read stuff from our component store? Well, we can use it with a select method. Select method will take the state and you explain, it will take the callback that takes state as an argument. This is what we have right now in our component store as a state, and we'll show how exactly we're extracting the data. For example, in this case, it's fairly straightforward. We'll just do state.cart_items, meaning we're reading from that property. And that will be an observable of cart items. Now we can listen to it wherever we want. However, we can do even further. We can select that observable, pass an observable into, and pass that function that transforms those cart items to the count. And then we have another property, the cart items count observable. What's cool about select, it's highly performant. It has all the share replays you need, it has distinct little change, and moreover, it also unsubscribes when the component store is destroyed. So it's all built into that select, highly performant. Alright, so this is how we read. How would we write? How would we update our state? Well, oh yeah, by the way, this is our read. So now in our cart icon component, we can just listen for this cart item count. We'll just inject the store just like as any other service would do and just read that property. Great, like this. Awesome, so how would we write now? Well, for that we have an updater. Updater is a function that describes how we change the values in our store, in our component store. And it takes two arguments. First is the previous state and the new value that's coming into it. For example, cart items in this case. And then it will returns an immutable version of new state. So how we'll spread the previous one, I will put those new cart items there as a property. So set cart items, it looks like a property, but it's a callable property. Now we can call that property and pass the new values into it. For example, as you see there highlighted at the bottom, the set cart items can take these cart items now and will update its state internally. So the updater takes the how we transform the state, how we update it. And finally, the side effect. In this case, it's add product. It's also a callable property, which will pass values into. So every time we want to add a product, we'll call the add product and pass a single value into it. For example, single string, single ID. But what effect does, it again orchestrates how we would work with those incoming stream of IDs. So that's why we work with observables. So notice the IDs is an observable, how we would work with those incoming IDs. Then we will pipe it, and there we have a chance to determine how exactly we want to control this race condition. For example, in this case is a concat map, meaning that for any new IDs that come in, we'll have to wait until the previous one is completely finished, and then the new ID will start looking at that one. What do you mean? What do I mean by completely finished? So for example, here, once I have an ID, then I'll call the cart service to add a product. So this is actually the one that would do the network request, bring us observable back. And when it's successful, then I do something with that value. So in this case, for example, on a success, I will push this new array of cart items into our state with the updater. If there's an error, I'll change some status. This could also be an updater, so update status. And finally, I'll catch the error and map it to the empty observable, meaning so I don't want to collapse my, my observable chain. Moreover, in the version 11 that's coming out in somewhere late November, early December for NgRx, we introduced the new operator called tap response. That's basically does the same thing that you just saw, but just a little bit shorter. Hey, no boilerplate now. Alright, so this is our side effect. Let's see how we can use our side effect. So now, in our component, we'll inject this cart store, and every time we need to add a product, what we'll do is just cart store.add product and product ID. Notice our product ID is a single string, right? And what we have instead there, it was an observable of IDs. And this is the beauty of side effects or effects, is that we can really control how we handle this. So every time we push the new product into this into the store, we have a way to handle those race conditions. So here is a concat map, but we could have chosen say merge map or exhaust map or switch map. Switch map would do, for example, if we're working on adding another product already, right, and the new ID arrives, we'll stop adding the previous one and start working with the new one. Exhaust map would do the reverse, meaning if it's working already on something, it's adding something already, it'll ignore any new values until it's busy adding it. So if you have a second one, it's like ignore it. And merge map, it will start them in parallel. This is what our service with the behavior subject does by default. But here we can really control it, be very specific, and all this complexity is no longer incidental. We're very specific how we want to handle those race conditions, right? So now we finally have that control, and moreover, I'm very explicitly asking to handle the errors here, because this is one of the biggest sources of error of broken applications as well. All right, so now we had that. Instead of calling it every time, we'll do what we'll do instead. We'll have a cart store that's provided in root, in this case, and then we'll inject it, and each would be listening for these selectors that it needs. So how does it compare before and after? Well, you see it here. It's not, inflating our code too much. However, what we get instead with the component store versus the service with the behavior subject, what we instead get is a highly performant, highly specific store that really handles all those race conditions, errors, and everything else in between. Awesome. So that's one of the use cases, right? A provider root. So where else can we use the component store? Well, provider root was one of them. And while I show you here how to do it, this is not the one that I would recommend too highly, because it basically brings back multiple services that are provided in root, which could cause this spaghetti of services, or what I call service soup. What I do recommend is the other three approach instead. And there's actually a good value sometimes to do the provided in root. If the component store is responsible for a very highly narrow scope of state, for example, like permissions, right? Permissions are used all over in the application, but it's very small state, but used widely. So that one's okay to be provided in root. That's why I have this exclamation mark. But then I have other examples where component store really shines. For example, a complex independent component state. Let's take a look at that one, for example. All right, so it's very similar to what we had before. However, our cart store is no longer provided in root, but instead it provided for a specific component. And that component basically is the first node that owns the state and that goes into the children. So it's the one that owns it. And when I say it's a component's called provider. So what does it mean? We use it providers in the component metadata. So we specify it there. Now our store will also be attached to the life cycle of that component, A in this case. That means that when that component is destroyed, when the user navigates somewhere else, the entire cart store is unsubscribed and cleaned up completely. So you don't have to worry about that at all. Awesome. Okay, so this is complex independent store. The next one is reactive local UI state. This is very interesting one. So for example, here in the component B, we have some state and we ship that state. We wanted to have it somewhere else, so our component becomes very lean and very effective. So we just put the business logic into the store beside it. This local store there is not used anywhere else in the application, only in the component B. But this is where our business logic now lives. It's provided for that component, it's injected in there, and it basically handles all our business logic now. So we can really easily test component B unit tested with mocking it all and just making sure our template works and all that stuff. And then we can really test the business logic separately through the component store. So this is the second example. And final example is the shared common component state. So this is a state where we have a common component that is used in multiple places in the application, maybe even at the same place. For example, here we have a component that has a parent component of A, and it interacts with it through input or output, right? So this component can be reused anywhere in the application. But this component could be talking to the network request and stuff like that if he wants to. So this is like a subtree there. And now we have a second common component that basically could live beside it on the same page, right? And each of them need to handle self-contained state. When we had, global NgRx store, for example, we were trying to push it way upstream and maybe index by something, and then you can use the queries to get each component independently. However, right now with the component store, each common component can just provide the common store, and because they are component scoped providers like ComponentStore, it would be unique for each common component. So for example, here each common component would have its own common store, completely independent. And then if you inject it somewhere deeper in the first or second level children's, they will have access to their appropriate common store. So this was the example that actually started the whole component store within Firebase, and later on, this is how it got into the NgRx. All right, so I'll do the quick summary. Synchronizing state is a complex task, and you have to be very specific how you do it. State management libraries help remove those incidental complexities and make it very specific. How do you want to handle your race conditions? I ask you to handle all the errors as well. So you remove a lot of complexity, and you think of state as a first-class citizen. And obviously NgRx to the rescue. Now we have global store, now we have component store. You can choose one or the other, or both actually, like Firebase Console does. They solve different problems, and they are really shine in the use cases where they solve. So thank you for all of these fantastic people. Kevin Yelko, who originally created the component store within Firebase, Brandon and Tim, who reviewed a lot of my code and had a lot of back and forth on the design and everything, and Nicholas Jameson from our XJS team, who actually created one of the custom operators that we use within the component store, and Lars as well for hours and hours and hours of basically going over some of the details of it and providing a ton of feedback as well there. So you can find all the info about the component store at our ngRx.io site. And don't forget to join our conversations at Discord, Discord GG Angular, and we have NgRx one as well. Lots of community discussions there. Definitely join that one. Thank you so much. Bye.